Okay, it's Tuesday, the first day of the Southern Manufacturing Show, and I'm on the Vision Engineering stand and talking to Steve Sanderson, International Product Manager, and he's going to tell us all about a brand new product that the company's launching at the show, and it's the Evo Cam. It's a HALO digital microscope. Before we get onto the HALO, Steve, just tell me about the other scopes in the range.
The Evo Cam range has been very popular. We've had Evo Cams for quite a few years now, and it's a very adaptable, very modular kind of system. So we find that it's used for a whole range of applications, everything from inspecting toothbrush bristles through to making bits that go into space. And it's that breadth of adaptability and breadth of application that makes Evo Cam really useful. The fact that a small business can be using it for one job in the morning and a different job in the afternoon, and it'd be as easy to use there as it could be in a big company where you have lines of them side by side, all working in the same job.
So how many different machines are in the range?
We've currently got 2 in the range so far, and the Evo Cam HALO makes that 3.
Okay, so let's get on to the HALO. Obviously, the star of the show. I guess its most prominent feature is the fact it's a 4K, which means really good image.
That's right.
Quality, but it also sports a number of other features. Adaptive illumination, intelligent software, super wide dynamic range, and a new enhanced illumination package. Can you just run through those for me?
Okay, of course I can. The good thing about the HALO is we've added these intelligent features to the camera to make it easier for people to use and easier to avoid the common mistakes that people sometimes do. So, for instance, in the lenses, we have the auto lens ID feature. So it's very simple to use. You put the lens on with a little bayonet kind of mount. The lens is automatically then recognised by the camera. So then all the settings within the camera will be adjusted according to that lens. So that you don't have to go into menus and remember to set something else in the menu that might be buried and might be easily forgotten. Automatically, those settings are changed. So if your inspection routine requires you to inspect it, say 10 times or 20 times, you know where you're supposed to be, not having made a mistake.
So how crucial is the 4K part of the scope? Is that a big step up?
4K is obviously kind of 4 times more detail than you get with a full HD system. And so for a lot of applications where you need to see that extra level of detail, it obviously delivers the extra image quality. But also not just in terms of number of pixels, because you've got a better spread of your of pixels on your image. It's better able to handle ranges of brightnesses. If you've got particular highlights or particular flare or reflections, the camera can adapt to that a lot better as well. So the overall image quality, not just the number of pixels, but in terms of the colour, the contrast within the image is so much better than you'd get with a full HD system.
Okay, you've already mentioned the HALO automatically detects the lens and it adjusts the magnification automatically. It does sound like the HALO's been designed with ease of use, and obviously it's a highly technical piece of kit, but it's got to be easy to use.
Exactly.
Was that a big part of its design?
It's very important to make things easy to use. Fatigue is a real problem for people. And businesses need to keep quality standards high at the start of the day and at the end of the day. And if we can do anything to make the product easier to use, to reduce the chance of making mistakes, then it's good for businesses, it's good for the users, and it's good for us as well.
And I suppose the ergonomics comes into that because, as you say, looking at a scope over a prolonged period of time can strain the eyes. What ergonomic features has the HALO got?
Well, binocular microscopes are synonymous with problems. The idea of hunching over a binocular scope where you have to look in can cause fatigue for the neck and for the eyes. And so using a digital camera system allows you to sit more comfortably looking at a screen that is a comfortable distance away and see the detail you need to see without having to compromise in terms of your posture. And so by having better posture, be more comfortable, again, without you reducing fatigue, and able to work better for longer and making less mistakes.
And I understand it works pretty seamlessly with your 360 direct oblique viewer.
Yes.
And I guess with the 4K you can see much more detail. I'm not really familiar with the viewer. Does that? I would imagine it's to be able to access hard to reach areas, hard to see areas, providing much more detail. Is that the idea behind it?
It's exactly that. Traditional microscopes are looking from the top down, and you're looking at a flat subject. Yeah. And as parts get smaller and as perhaps PCBs and things can be larger, so you're working at higher magnifications, it can be really hard to manipulate the subjects to look behind or underneath things, particularly things like J-legs or things on chips, where you want to make sure that things have been made the right connection, that solder's flowed properly. And so to do that, to make sure you can do that, you want to change your angle. But with larger components, it's hard to do that manually. So what we have with the 360-degree viewer, you're able to look at the whole board and zoom in to look at particular detail from a direct down view, locate what you want to inspect, and then switch into the oblique view, which gives us a 34-degree oblique angle, and we'll rotate 360 degrees around the subject.
Oh, so the operator doesn't have to move?
So the operator doesn't have to move.
Oh, right.
They don't have to manipulate things. It makes it much more comfortable for them to use, more efficient, because they're not trying to get things in focus. It stays in focus just as you're rotating around that point of interest.
I guess not everybody will actually need that functionality, but for those that do, it's there. It's an option, isn't it? It's an optional extra that you can...
Exactly, yeah. It is an optional extra. Not everybody needs it, but we find actually it's really popular. We always bring it to shows because people like to be able to see that actually you can do that.
We spoke about the hardware. What about the software side? Is that obviously that's as important? Has it got its own bespoke software, or do you have a piece of software that you use across multiple ranges?
We have on board. We have some features on board the camera as well, but also we support the camera with our VR Plus software. That's a very adaptable piece of software that was used on multiple systems. But for the Evo Cam HALO, it will control the camera as well as do things like measurements, and I'll provide overlays. Be able to bring in DXF files to compare against a DXF file, and so you've got a whole load of additional features that come with. You don't have the powerful kind of processing that you can get with a computer that brings in kind of extra level of functionality.
What sort of applications do you think that this is going to be particularly suited for? I mean, did you have a specific type of customer in mind, or is it designed to be versatile across multiple industries?
Well, Evo Cam as a product range is typically very versatile. I'm trying to keep it as versatile as we can. But we see sort of biggest demand in areas like electronics, as electronics are getting smaller. Lots of medical devices are very demanding, and again, they have a very, very kind of tight requirement as to kind of what they need and expect it to do. And this has got the features on there that was really targeted towards those guys as well. Yeah. But all the way through to, say, toothbrush manufacturers or Formula One car manufacturers.
Obviously, PES, the magazine I represent, is metal cutting and metal forming kind of base. Can you see an application there for looking at small metallic parts?
Of course. Yeah, sorry. It really is. I mean, in terms of the reflection control in it, metallic parts get lots of reflections, and trying to have a good, clear view of that is really important. And so we have, say, things like this panel light, which is specifically designed to help manage reflections. So you get a larger area of even illumination. So it overcomes the problems you get with reflection, so you can see a better, clearer image, particularly on cut parts, which could be prone to stray reflection.
Where would you keep these then? Where would you put the HALO? I mean, is it a lab type piece of equipment? Could it be on a shop floor environment? Well, where do you see the application?
HALO is designed to be robust, and the Evo Cam range has been robust, and we found over the years they put extra machines on the shop floor as well as they are in the R&D lab, and they are adaptable. But HALO has been designed to be really easy to use and really, really rugged, so that if it's on the shop floor next machine, you can take your part and bang it straight underneath, and anybody can use it.
Is it available now? The final question from me: is it available now? Are you able to? I think in the press release there is something about the price as well. Are you happy to divulge what that is, or is it going to depend on application?
In terms of availability, we're very pleased to be able to preview the product here at the show. It won't be available till 2nd of April is when we do an official kind of launch for it. So that's when products will start to become available to sell. Until before then, we'll start to get some demo units out. In terms of price-wise, it's going to be in the same sort of price point as the Evo Cam.
Okay.
And so it just, so to say, it fits the Evo Cam range. But as a modular system, price will depend exactly on
Yeah, it depends what
which
you.
combinations you go for.
Yeah, yeah.